It's a puzzling round of find the stowaway. At the point when we wonder about the photos taken during manned space missions, a vital detail generally is by all accounts missing: the stars. But why is that so? After all, it's not difficult to recognize the thousands and millions of shimmering stars overhead on Earth. In fact, the missing stars in the Apollo photographs are even referred to as assumed proof that the pictures were not really taken on the moon by any means, but in a secret film studio. However, does it have to be so conspiratorial, or is there a much simpler explanation for the strange shortfall of the brilliant heavenly bodies? And above all, what does a space explorer truly see when he enters the unending spread of space? We all know Yuri Gagarin, and we all know Neil Armstrong, but have you heard of Bruce McCandless? Like his more famous astronaut partners, the American also made space history. On February 7, 1984, McCandless became the first person to complete a spacewalk without a safety line. Anyway, the trailblazer walker didn't need to manage without a little assistance. When McCandless left the space shuttle, he was carrying a 140 kilograms rocket motor on his back that allowed him to move in space. In the end, he spent 4 hours and 55 minutes in space this way, and he climbed to 100 m away from his spaceship. Right away, you may believe that such an introduction to the limitless void would be unbelievably quiet, almost thoughtful. Yet surprisingly, McCandless didn't describe his unstable space trip as peaceful. In hindsight, in actuality, on the one hand, there was the space debris in Earth's orbit, which can rapidly develop more penetrating power than a gunshot, and which would have turned the mission into an all-out disaster if it had hit. And then there was astronaut Bob Stewart, who also ventured into the deep black of space shortly after McCandless. Also, the ground team and the other crew members in the space shuttle who were talking wildly through the radio the whole time. As a result, McCandless later summed up his notable walk with the single word, loud. But if you like, this description is a stark contrast to the photographs that subsequently went around the world, as they leave us completely puzzled. They show a solitary astronaut, seemingly floating alone through the vastness of the universe, away from Earth, which appears in the photos as a radiant blue circle. Only the totally dark vastness greets us in the background. But why is that really the case? Shouldn't the scene be spilling over with endless stars? Well, of course it should. After all, our Milky Way alone is home to an estimated 100 to 200 billion of these shimmering formations. But if the stars are there, why can't we see them in the photographs? How do the stars become invisible? Another mission, same picture. As is well known, the photographs of the Apollo 11 mission also show a confusing celestial game of find the stowaway. But shouldn't the stars have been especially easy to see due to the moon's lack of atmosphere? Well, you may think so, and where the brilliant heavenly bodies are hard to come by, it is considered more likely in certain circles that it was too complicated for the set designers in their secret film studios to reproduce the thousands and billions of stars in the right constellations. The official explanation, on the other hand, sounds somewhat different. It justifies the absence of stars with the short exposure time of the photographs. Essentially, the surface of the moon reflected the sunlight so strongly that not even the astronauts themselves could see the stars. To make the weak objects in the background visible, the pictures would have had to be exposed for a long time. But this would have resulted in the astronauts and the lunar surface being overexposed, making them unrecognizable. A short exposure time hides the stars overhead, but as a result, it shows the real subject of interest, specifically, the Apollo astronauts at work on the moon. And of course, NASA didn't send people to the moon to capture particularly beautiful pictures of the brilliant sky. After all, this could also be done from Earth. Consequently, the cameras were purposely set to short exposure times, and anyone can easily confirm for themselves that this is accompanied by the optical disappearance of the stars. Considering that the Earth's atmosphere is relatively transparent to light, anyone who snaps a picture of the night sky with a short exposure time will see that no stars are visible on it. And generally, we should not forget that the stars in the photographs taken by the space missions are not isolated. In other words, the darkness of space is constantly distorted by the brilliant environmental factors of the astronauts, the spaceship, the space station, the crew, and, of course, solar radiation. All of these produce a significant amount of light that surpasses the background stars, which are equally faint. This effect is already clear to us when we look at a street lamp that lights up the night sky near it and makes the stars invisible. But even if the environment were darker, thus aiding the space missions, the heavenly field of view of astronauts would still be limited. In fact, this initially sounds like an inconsistency. After all, there is no atmosphere in space to block the starlight. However, this is also related to the fact that there is no light scattering in the immensity of space. Without light scattering, stars appear as tiny spots that must be checked if they shine brightly. And how this theoretical system is put into practice becomes clear when we listen to the report by Canadian astronaut Chris Hadfield. Having gone into space 3 times between 1995 and 2013, Hadfield helped assemble the robotic arm on the ISS during 2 extravehicular activities. He described the scene before his eyes as follows: "You hang on with one hand and watch the world spin by. It rushes quietly past you with its colors, and if you take your eyes off it and peer down at the rest of it, you see an impossible darkness with a surface that makes you feel like you could stick your hand in." What Neil Armstrong announced about his perspective on space sounds very much like the first man on the moon. Said the sky is totally dark when you take a gander at it from the moon, very much like from the CIS lunar space, the space between the Earth and the moon. Armstrong also noticed that from the lunar surface, he could see the Earth and the Sun, but no stars. However, maybe he was fortunate to have the option to see anything at all after the Apollo 11 mission, about space explorers with poor vision and technical obstacles. Right now, it should be noted that although the perspective on the Earth from space is an extraordinary experience, it's also connected with high risks. In reality, around 2/3 of space travelers on long-term missions report that their vision is quickly deteriorating. In the case of John Phillips, his vision even decreased from 100% to 20% following a half-year in orbit. But why is that actually the case? Well, in this respect, NASA specialists have found that the so-called visual impairment and intracranial pressure (VIP) disorder, for short, isn't due to the brilliant reflection of any surfaces, but to the effects of weightlessness. This is because it causes the amount of cerebral fluid to increase significantly, which then pushes on the highly sensitive structures in the eye. The result is reduced blood flow and damage to the optic nerve. Unfortunately, studies have shown that this deformity inside the eye and the related visual impairment do not always disappear after the astronauts return to Earth, which makes the camera-based perspective on space appear to be a lot better. Well, for as long as it wasn't really limited, of course. But is it by any means later? After all, we all know those space photographs that blow our minds with their incredible details, and they do indeed show stars. Anyway, the subtleties of the establishments for a successful picture in space are laid ahead of time, because not at all like our students, most space cameras are not equipped with openings that allow them to adjust to changing light circumstances. Rather, scientists predict the lighting conditions that a camera will experience during its mission and build the instrument's apertures accordingly, ensuring that they are appropriately measured for the range of anticipated targets. And then, as already mentioned, there is the exposure time. Consistent with the aphorism, longer exposure times catch more light. The pictures that show us the night sky as a brilliant exhibition are long-term exposures that often last many minutes. Furthermore, now space cameras are also capable of covering an extremely wide range of exposure settings. For instance, the technical eye of NASA's New Horizons probe is capable of taking pictures with exposure times between 1 millisecond and 30 seconds. When the spacecraft passed Jupiter, which is much closer to the Sun and therefore substantially brighter than Pluto, the shortest exposure time was chosen for the far-off structures of the Kuiper Belt. The longest exposure time was used unexpectedly. This too answers another often asked question about space pictures. How could cameras take pictures so far from the Sun, where the light is so weak? The answer to this question lies in a combination of highly sensitive cameras and, if necessary, long exposures. But what happens when the cameras are not sensitive enough for their mission? This becomes clear when we look at a couple of old Voyager 2 snapshots, initially intended for the conditions on Jupiter and Saturn. The camera crashed while trying to capture the structures in the overall darkness of Neptune. And thus, It happens that the best Voyager 2 pictures of the Neptune moon Proteus just look like a heavenly body when we close the two eyes. And we'd like to remind you to tap on the two buttons beneath our video, start with a like and then subscribe, so you never miss another post from us in the future. We'll see you soon.